Hello everyone, my name is Fanyi Xiao. This is a joint work with my advisor, Professor Yang J. Lee at the University of California, Davis. So the goal of this project is to build an algorithm that could output object proposals for videos. Specifically, given an input video, we want to output object proposals both at the box level and also at the segmentation mask level. So there are many previous work that are related to what we are doing. The first line of research that's closely related is video proposal and segmentation. Another line of research that's loosely related is visual tracking. However, for most existing video proposal method, they either perform some sort of clustering over all frames, which is hard due to the large appearance variation, or they track the object instances starting from the first frame, which is prone to drift. On the other hand, tracking method usually requires supervision. In this project, we don't want supervision, while at the same time, we want to overcome the difficulties encountered by the existing methods. So among all this, our approach is particularly related to the key segments approach of Lee et al. 2011, which has this idea of discover easy instances first. Despite the concept level similarity, our method has significant difference to the key segments approach, which we will later demonstrate to be essential to our approach. So the first key contribution of our method is the idea of initializing clusters of easy instances that are spread out in time. So like key segment approach, we initialize by forming clusters of easy instances. However, instead of directly retrieving nearest neighbors, which leads to the results of the retrieved boxes mostly coming from nearby frames, we directly enforce the constraint that we want the boxes to be spread out in time. So this gives us initial clusters of objects that are occurring consistently throughout time. The second key contribution is the idea of iteratively grow from easy instances, and this is a key difference to the key segment approach. So with the initial clusters, one simple thing one can do is to use the detector trained from the initial clusters to search for the object instances across all frames. But this approach is prone to drift. Whereas instead, we propose to iteratively grow from the initial clusters to give opportunity to our model to adaptively update itself according to the changing appearance. And this makes us less prone to drift. So the third contribution is that after we got the box proposal, we convert it into segmentation proposal using a grab card style algorithm with a hypercolumn pixel feature. So the advantage of this compared with, for example, starting with the pixel at the very beginning is that we significantly reduce the computation cost while still being able to produce good segmentation results. So here are some qualitative results. The first 3 rows are for boxes and the last 3 rows for segmentations. So as can be seen, our method is robust to various challenges like scale, rotation, and illumination variation, and is also able to tackle very thin structures like bicycles, for example. So here are more qualitative results. So in terms of quantitative results, we achieved the state-of-the-art results for video segmentation on the SegTrack v2 datasets, and also we achieved comparative results against several supervised tracking methods on the visual tracking benchmark. So finally, we use this work in another paper from our lab, which has this idea of making use of the temporal information in the video to help better localize objects in static images in the scenario of training weakly supervised object detector. And we achieved state-of-the-art results on Pascal VOC datasets. So please come to see both our posters. Thank you.